the chemistry workbook today and actually doing chemistry. So here we go. Chapter 1. This is found on page 74 of your notebook or your workbook. So we want to define the following terms so that we can start understand what's going on in chemistry. So here we go. Chemistry. We're going to define chemistry. Chemistry is defined as the study of matter and how it interacts. Also, the study of the energy in those interactions. Okay, so our next thing that we need to discuss is matter. What is matter? So matter is anything that has mass and takes up space. Okay, so then what is mass? Mass, this is going to sound like a kind of circular definition, but mass is the measurement of the amount of matter that an object has. So what has mass? Well, I have mass, you have mass. This pen that I'm using to write with has mass. Even the air around us has mass. So almost everything that we can think of has mass. A lot of people get mass and weight confused. So the thing that I want to tell you about the difference between mass and weight, mass doesn't change. So anywhere I measure the mass of an object in the universe, that mass is going to be the same. Weight, though, does change because weight is the measurement of mass under the gravitational influence of a gravitational field. So it's the force of gravity acting upon mass. Okay? So for example, if I went to weigh myself on the moon, I would weigh about 1/6 of what I weigh here on Earth on the moon. Because the moon's gravitational field is about 1/6 of the Earth's gravitational field. But if I went and weighed myself on Jupiter, for example, I would weigh tons and tons of pounds, or if we want to do that, newtons in the SI system. I would weigh so much on Jupiter that my body would actually crush in on itself. Okay, so here we go. Some branches in chemistry. This is not by any means an exhaustive list. This is a very basic list. So here's some basic branches. We have organic chemistry. Now, when we think of organic in the normal vernacular that we use, we think of organic being natural or chemical or pesticide free. That is not what we mean in chemistry. What we mean in chemistry with organic is it's got carbon in it. So even things that we think of as being very unorganic, like plastic or pesticides or those kind of things, those are organic chemistry because they have carbon in them. Okay. Inorganic chemistry. This is pretty much what we do in general chemistry. We talk about all things that don't contain carbon. So this basically is what you're going to get as an inorganic chemistry class this year. Physical chemistry is based on the behavior and changes of matter and the energy changes. So this is where physics and chemistry go in together. We're talking about how quick a reaction will happen, how a reaction happens, and all of those kind of things. Analytical chemistry is basically, we're trying to figure out what makes up stuff. So sometimes we will have something that we don't quite know what it is made from. We are trying to find the components and the composition of those substances. We use it a lot for quality control on our manufacturing and food processes to make sure the food and things that we have manufactured are actually what we want them to be. Biochemistry is where biology and chemistry meet. So we are talking about the matter and the processes of living organisms. So how things go within a cell, how things work within a cell on the molecular level. Environmental chemistry, we are talking about the chemistry and the chemical reactions of the environment and pollution and how it interacts. So those are the things that we are looking at here. Industrial chemistry is a broad thing too. Any process that is done on the industrial scale is industrial chemistry. So how our gasoline and how our plastics are manufactured, even how our cars are manufactured, the paints going on our cars, that is all industrial chemistry. Polymer chemistry is polymer. Polymer means many. So when we're putting many little things together, that is a polymer. A polymer that you are probably really familiar with is nylon or polyester. Polyester has poly in it. So it's many esters put together to make that polyester fabric. We usually think of textiles, coatings, plastics as polymer. Theoretical chemistry, this is almost purely academic. We are talking about chemical interactions and pushing the limits of what we know of chemistry. So that is a very academic enterprise. And last but not least, we have thermochemistry. Thermo is all about heat. So we're talking about heat and the energy exchanges within reactions. So there's some general chemistry areas. We would like to classify matter here. There are two main areas of matter. So when we talk about main areas of matter, we have pure substances, and we have compounds. Or no, sorry, wrong thing. We have mixtures. I should say mixtures. Okay, so those are the two main things of classifying matter. So pure substance, it's matter with a uniform or unchanging composition. Basically, I can write a chemical formula for it. Okay, so we have two types of pure substances. One of those is an element. So if I have a pure substance that is an element, that means I have something that's made out of just one type of atom. So if something is made out of just one type of atom, I could have something like gold or oxygen or zinc or iron. Those are things that we use on an everyday basis that are just made out of one type of atom. So we call those elemental things. Compounds, on the other hand, are a pure substance, but they're made out of two or more types of atoms. So these guys have two or more types of atoms in their chemical compound. So here's some pretty easy examples. Water. We have two hydrogens chemically bound with one oxygen to make up water. Or we could have something like salt. What you call table salt is made of sodium and chloride put together. Or sugar, in chemistry speak, is sucrose. I will have 12 carbons, 22 hydrogens, and 11 oxygens in one molecule of sugar or sucrose. Okay? Compounds cannot be separated into their elements by physical means. The only way that we can separate these elements from each other is to do it by chemical means. Okay? So those are pure substances. Let's go on to mixtures. Mixtures are a combination of two or more pure substances in which each pure substance retains its individual properties. We have two types of mixtures. We have heterogeneous mixture. Hetero means different. So when I have a heterogeneous mixture, that means I have a mixture that is not uniform. It is not uniform throughout the mixture. So an example of a heterogeneous mixture that you might be pretty familiar with would be like a chocolate chip cookie. We've got the chocolate chips in the middle of that cookie dough, all spread out. You'll have some chunks of chips and chocolate in there, and then you'll have dough. It's not uniform. Where those chips are is pretty random. There's two types of heterogeneous mixtures. Actually, there's more, but there's two main types. There's a colloid where the uniformity is actually pretty small. So the chunks or the little bits of the mixture are so small. We have small particles. No, I can't spell. Let's erase that. We have small particles that are so small they don't settle out. When not agitated. I'm going to say mixed. So if I don't shake it or stir it or mix it, those particles are so small that they don't settle out or come to the bottom or separate out. A really good example of that would be mayonnaise. So mayo is oil mixed with water with egg yolks and vinegar. That doesn't separate out because we have whipped that so small that the little droplets of oil are so small that they don't separate out. We use the egg whites as what we call an emulsifier to mix things together. Suspension, we have larger particles. That do settle out when not mixed. For example, if I had sand and water, if I stopped stirring that sandy water, the sand would go to the bottom. So that is the difference between a colloid and a suspension. Next, we have homogeneous. Homo means same. So if I have something that's the same and it's a mixture, that means my mixture is uniform. This is uniform throughout. I'm not going to find chunks of anything. Homogeneous mixtures are also called solutions. So when we talk about homogeneous mixtures, the particles of whatever is making it a mixture are so small that we are down to the molecule level. So they can disperse evenly throughout that whole mixture. Mixtures can be separated by physical means. We can do filtration. Think about your water filtration. We are separating things by size. So if I have a water filter, I'm using that water filter to get bigger chunks of bigger molecules out of the water. Water molecules are really small, so they can go through almost anything. And then I can keep those bad parts out that I don't want to have in my water. Distillation, we are separating things out by boiling points. So if I have a homogeneous mixture, say I have some salt water. So if I have some salt water, if I boil that salt water, the water turns into steam or gas vapor. And if I keep on boiling that water, at the end of the water being all gone, I will have crusty salt left in that pan that I've used to boil the water. So I've separated the water from the salt by the difference of their boiling points, because water boils a lot sooner at a lot lower temperature than the salt. Chromatography, I will put a demo video of chromatography on. We are using the ability of molecules to travel through what we call a solid phase versus a liquid phase. Some things travel in water or the liquid phase a lot better than solid phase. So if you ever accidentally gotten a paper wet that has had marker on it, and those have been like Crayola markers or any other water-based markers, have you seen kind of that blotchy water ring where the ink kind of travels to the edges of that watermark? And you have different colors depending on the ink that was in that original drawing. That is chromatography. We are separating things out by having the water, the liquid phase, and the solid phase, the paper, and how they move in relationship to each other. Okay, that's enough for now. We're going to start going into matter and review a little bit, and then we will wrap it up by talking about physical and chemical properties.